The strange thing is, we may already be living in a world where teleportation isn't just a fantasy, it's a reality. Not the dramatic Star Trek beam of light, not people vanishing from one place and reappearing in another. Something quieter, something hidden, something so subtle that it has been unfolding under our noses, without most of us realizing it. When scientists talk about quantum teleportation, they're not describing science fiction. They're describing a process that has already been achieved in laboratories across the world, and not just once, but repeatedly, consistently, and with increasing levels of sophistication. Photons have been teleported across dozens of kilometers of fiber optic cables. Entire states of quantum information have been transferred across vast distances, sometimes even involving satellites orbiting the Earth. In other words, teleportation is not a dream for the future. It's here. But here's the unsettling part. If quantum teleportation is real, and if it's quietly being refined by physicists and engineers, what does it actually mean for us? Does it mean that one day a human being could be teleported, body, mind, memories, from New York to Tokyo instantly? Or does it mean something even stranger, something that challenges our very idea of identity, location, and presence? Think about it. The first time humans split the atom, no one outside the labs realized the implications. It seemed like obscure research tucked away in academic journals, yet within a decade, it had changed the entire balance of power on Earth. Could it be that quantum teleportation is following the same path? That today, it looks like an esoteric experiment with particles of light, but tomorrow, it could rewrite how we connect, how we travel, even how we exist? And maybe the wildest twist is this. Teleportation might not come with any fireworks. No glowing portals, no crackling energy, just a silent transfer of reality itself, happening in a way that makes you wonder whether we'd even recognize it when it arrives. So if it's already happening, if the first steps of teleportation are already out of the realm of fiction and into the realm of fact, what exactly is being teleported? And what does that reveal about the nature of reality itself? To understand what's truly happening when we talk about quantum teleportation, we need to strip away the sci-fi illusions and dive into the actual mechanics. Teleportation in physics isn't about moving an object from point A to point B. It's about transferring information, the exact quantum state of a particle, without physically sending the particle itself. Here's how it works. Imagine two particles that are entangled. This means their states are mysteriously linked, no matter how far apart they are. If you measure one, the other instantly knows. Now let's say you want to teleport a particle's quantum state. You take a third particle, the one whose state you want to transfer, and make it interact with the first of the entangled pair. Through a clever measurement, that quantum state is destroyed at the origin, but reappears on the distant partner. The particle itself didn't travel. What moved was the essence of its identity, its blueprint, its informational fingerprint. This is why physicists call it teleportation. Because the original state is gone, wiped clean, and yet the information has leapt across space and manifested in a new particle elsewhere. In 2017, Chinese researchers pulled this off across more than 1,200 kilometers using a satellite called Mycius, teleporting quantum states between Earth and orbit. No wires, no physical travel, just pure state transfer. Since then, experiments in the US and Europe have extended teleportation through fiber networks, laying the groundwork for what's now being called the quantum internet. But here's the unsettling twist. If teleportation is about information, not objects, doesn't that mean that reality itself might just be information? Your body, your thoughts, your sense of self? Perhaps they're nothing more than configurations of data. If so, teleportation stops being a trick with photons. It becomes a possible roadmap for moving the essence of anything. Think of the implications. Teleportation isn't just the dream of instant travel. It's a window into the idea that matter is secondary and information is primary. Once you accept that, the boundary between here and there, this and that, starts to blur. We aren't as fixed in space as we thought. And here's where it gets even stranger. If the state at the origin is destroyed when it's teleported, then in some sense, what arrives on the other side is not the same thing, but not a copy either. It's the state reborn, which raises the question, when humans eventually attempt teleportation, will the person who steps in be the same one who steps out? Or will something unthinkable happen in between? Here's where things get deeply uncomfortable. Our common sense tells us that teleportation should work like a courier service. You put something in a box, ship it, and the same thing arrives intact at the destination. But quantum teleportation laughs at that intuition. It doesn't deliver the original, it deletes it, then reconstructs its essence somewhere else. This flips our entire sense of reality upside down. We like to think of objects as solid, permanent, continuous. A chair stays a chair, your hand stays your hand, you stay you. But teleportation suggests continuity might be an illusion. The moment something is teleported, its original state is obliterated. What emerges on the other side is indistinguishable, yes, but technically it isn't the same. It's a perfect recreation, built on information, not matter. Let's test this with a mental exercise. Picture a playing card. You hand it to a magician. He shreds it into pieces right before your eyes. Gone. But then, in the blink of an eye, he pulls the same card perfectly intact from his pocket. That's what teleportation is doing, except this isn't sleight of hand, it's physics. The destruction is real. The reconstruction is real. And in between, there's no card at all. The discomfort comes when we stop thinking about photons and start thinking about ourselves. If your quantum state could be teleported, would you still be you? Or would you die in one place and be born again in another? Common sense insists there's a thread of continuity holding us together, but teleportation suggests continuity is just a story we tell ourselves. Critics push back here. They argue that identity isn't just information, it's embodied. It's tied to your atoms, your specific matter, your biological history. But quantum mechanics keeps dismantling those assumptions. In experiments, particles show again and again that their individuality doesn't matter. What matters is the state, the configuration of information. A particle doesn't care if it's the same one as before. All that matters is that it behaves as though it is. So maybe identity, continuity, and location are illusions born from our scale of experience. Maybe teleportation is exposing that reality is fundamentally about information transfer, not object persistence. And here's the paradox that eats at the edges of our logic. If teleportation doesn't preserve the original, then how can we say it's the same thing at all? If what arrives is a flawless replica, but the original is gone forever, what does same even mean? If all of this sounds like philosophy wrapped in physics, let's ground it. Teleportation isn't speculation. It's experiment, replication, and evidence. And the ladder of proof is already shockingly tall. Step 1. The photon experiments. In the 1990s, physicists proved that quantum teleportation was possible in principle, transferring quantum states of light particles across short distances. At the time, it seemed like a parlor trick for hardcore theorists, but it established the foundation. Information can leap without matter traveling. Step 2. Scaling up. Over the 2000s, scientists pushed teleportation further through fiber optic cables, reaching kilometers of distance. This wasn't just theory anymore. It was engineering. Teams in Switzerland, the US, and Japan all confirmed the effect. The fidelity, the accuracy with which the state was preserved, kept improving, closing in on perfection. Step 3. The satellite leap. In 2017, China stunned the world with the MISHIS satellite experiment. Researchers teleported quantum states between Earth and space, a distance of 200 kilometers. For the first time, teleportation left the lab and touched the global stage. Suddenly, teleportation wasn't confined to basements and test tubes. It was orbiting above our heads. Step 4. The quantum internet frontier. In the last few years, projects in the US, notably at Fermilab and Caltech, have linked multiple nodes of a quantum network using teleportation. What's emerging is not just faster communication, but communication that is, in principle, unhackable. Because when you teleport information, there's no signal traveling through space that can be intercepted. Hackers can't tap into what doesn't move. And here's the quiet bombshell. Governments and private labs are racing to build these networks. The US, China, and Europe are investing billions. The result? A hidden arms race of teleportation technology that most people don't even realize is underway. This ladder of evidence tells us something astonishing. Teleportation is not only real, it's advancing faster than the public narrative admits. If photons today, why not atoms tomorrow? If atoms tomorrow, why not molecules after that? The roadmap is already being traced, but the higher we climb this ladder, the shakier it gets. Because each new step doesn't just prove teleportation works, it raises deeper questions about what's actually happening. Are we transferring reality itself? Or are we just convincing ourselves that replicas are good enough to count as the original? And if teleportation keeps advancing, at what point will we have to confront the most disturbing question of all? When does teleportation stop being about particles and start being about us? This is where teleportation stops being a physics experiment and becomes a philosophical earthquake. Because if reality is transferable information, then the borders we cling to between objects, places, even selves, may be far less solid than we imagine. Think about what teleportation really tells us. Matter is not fundamental. What matters is the pattern, the quantum state, the informational structure. A photon doesn't care if it's this photon or that photon. If the state is preserved, physics treats them as the same. Now apply that logic to higher scales. If all you are is information, then you could, in principle, be teleported, reconstructed, and continue seamlessly. Or maybe not. Here's the shockwave. Teleportation forces us to ask whether identity is absolute or relative. Are you defined by your specific atoms or by the information they carry? Every 7 years, almost every atom in your body has been replaced through metabolism. Yet you don't feel like a different person. Continuity doesn't come from matter. It comes from structure. That's exactly what teleportation leverages. Critics push back hard. Some argue that teleportation is nothing but copying, and that calling the replica the same is a semantic trick. To them, the original is gone forever, and what appears elsewhere is just an imposter. But defenders counter, if the replica is indistinguishable in every measurable way, memories, personality, even quantum fluctuations, then what basis do we have for calling it an imposter? The word copy itself loses meaning. Others argue from a more pragmatic angle. Teleportation isn't about metaphysics, it's about networks. Quantum teleportation will never move people, they say, only information. It will give us faster computers, secure communications, and new technologies. But here's the danger in that argument. Every radical technology starts as just information. The internet was once just a network of academics sharing data. Today, it defines almost every aspect of our daily lives. What begins as information transfer rarely stays confined, and that's the real philosophical weight here. Teleportation isn't just about whether one day you'll beam across the globe. It's about whether the universe itself is fundamentally digital. If teleportation works because information is the bedrock of reality, then we're not living in a solid, continuous world. We're living in something like a code, where patterns can be destroyed and recreated without loss. That's not just unsettling. It's destabilizing. It suggests that permanence is a story we invented. It suggests that location, self, and even time might not be as fixed as we thought. And if teleportation keeps working, if experiment after experiment keeps proving that reality can be transferred without moving matter, then maybe the real science fiction is the assumption that we're continuous beings at all. So the question isn't just, can we teleport? The question is, what does teleportation reveal about what we already are? Let's look forward. Because if quantum teleportation is already real, even at the level of photons and quantum states, then the question isn't if it will scale up, but how far. The first obvious horizon is the quantum internet, a global network where information is teleported between nodes instead of transmitted through signals. This changes everything. No signal, no interception. Communication becomes unhackable, instantaneous, and secured by the laws of physics themselves. Imagine financial systems where fraud is impossible. Governments exchanging secrets that no spy can ever access. A digital world where trust is enforced not by institutions, but by teleportation itself. The second horizon is quantum computing. Teleportation isn't just about communication, it's about connecting quantum computers into something greater. Right now, quantum processors are fragile, limited by decoherence and noise. But if teleportation can link them into vast, distributed networks, we're talking about a computational power that dwarfs anything humanity has ever known. Problems that would take classical computers billions of years could be solved in seconds. Chemistry, climate, medicine, artificial intelligence, all accelerated. Teleportation becomes the invisible glue of a new machine intelligence. The third horizon is materials and biology. If teleportation can faithfully transfer states of photons and atoms, what about molecules, proteins, DNA? Scientists are already testing quantum effects in biology, photosynthesis, bird navigation, even the way smell works. If these systems rely on quantum information, then teleportation might one day allow us to move the functional essence of biological systems across space. A cure for a disease teleported directly into a cell? A genetic sequence beamed from one lab to another without ever being sent? It sounds like science fiction, but so did satellite teleportation 20 years ago. And then comes the horizon no one wants to talk about: teleporting humans. Most physicists insist it's impossible, at least in any practical sense. The complexity of the human body, the sheer amount of information involved, makes it overwhelming. But history is littered with impossible technologies that eventually became routine: electricity, flight, space travel. The problem isn't whether it's theoretically possible. Teleportation already proves the principle. The problem is scale, engineering, and time. But if that day comes, we're forced into a terrifying crossroads, because teleportation, by design, destroys the original state. To teleport a human would mean annihilating the person who steps into the machine. The one who appears on the other side would be identical in every way, but would they feel like they had traveled? Or would the traveler vanish forever, replaced by someone new who merely believes they are the same? And here's the cliffhanger. If teleportation already blurs the line between original and copy, then when the first human steps into that machine, how will we even know whether the person who walks out is truly them, or just a ghost made of perfect information? Let's bring this down to you. Not the labs, not the satellites, not the quantum networks. You. What does teleportation really mean for your everyday existence? First, it challenges how you think about presence. You've always assumed that being somewhere is about your body occupying a place. But if teleportation is real, even at the scale of photons, then presence is less about location and more about information. You're not fixed. You're a configuration that could, in principle, exist elsewhere. Suddenly, here and there lose their sharp edges. Second, it reshapes the meaning of communication. Every time you send a text, make a call, stream a video, you rely on signals traveling through space. That takes time, energy, infrastructure. But teleportation hints at a future where information doesn't travel. It simply appears. Imagine talking to someone across the world without lag, without wires, without satellites. Information wouldn't just move faster. It would feel immediate, as if distance had been erased. What does a world look like where distance no longer separates minds? Third, it stirs questions about identity. If everything about you can be described as information, then who are you, really? Are you a continuity, a story that unfolds without break? Or are you a constantly updated state, reconstructed moment by moment? The unsettling part is that quantum teleportation sides with the second answer. And if that's true, then you're not as permanent as you feel. You're not a fixed object. You're a process. Fourth, it touches trust. In a teleported world, trust doesn't come from institutions, governments, or companies. It comes from physics itself. A message sent through teleportation cannot be hacked, intercepted, or forged. That means privacy, security, and truth could be built into the fabric of reality. But it also means we'd be forced to give up the comfort of control. You wouldn't trust because you chose to. You'd trust because you had no other option. And finally, it hits fear. Because if teleportation works by destroying the original, then you have to ask, would you ever step into the machine? Would you gamble that what comes out on the other side is truly you, with your memories, your emotions, your sense of self? Or would you feel that stepping in means surrendering forever, leaving behind a perfect stranger who only thinks they are you? This is what teleportation does to the human mind. It strips away the illusions of stability we lean on every day. The ground beneath your sense of self starts to crack. And in those cracks, a new possibility emerges. Maybe you are already less solid, less continuous, less fixed than you ever dared to believe. So here we are. Teleportation is no longer the glowing beam of science fiction. It's a quiet fact of modern physics. Photons already vanish in one place and reappear in another. Quantum states already leap across satellites and fiber networks. The extraordinary has slipped into the ordinary, unnoticed by most of the world. But what does that leave us with? Not a promise of instant vacations to Mars, not yet. Instead, a deeper truth. Reality is fragile. Identity is not guaranteed. Presence is not fixed. Teleportation forces us to look in the mirror and admit that what we call the self might be nothing more than information, constantly rewritten and rebuilt moment by moment. And yet, there's something liberating here. If you are information, then you are not trapped. You are flexible, fluid, adaptable. The boundaries you thought were absolute, between places, between people, even between me and not me, may only be stories. And stories can change. The real revolution of teleportation won't be when someone beams across the globe. It's happening right now, quietly, in the way we start to question what it means to be anywhere at all. Maybe teleportation isn't about moving through space. Maybe it's about waking up to the fact that we were never as solid as we thought. Picture yourself standing in front of a calm lake at night. The stars are reflected in the water, perfect, shimmering. You look up, the stars are there. You look down, the stars are there too. Which ones are the originals? Does it even matter when the reflection is indistinguishable from the real thing? Teleportation whispers the same riddle. Maybe originality is irrelevant. Maybe what counts is continuity, experience, awareness. So I'll leave you with this question. If teleportation is already real at the quantum level, what happens when it climbs up the ladder to us? Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.